We are continuing on in our section of 1.1 in college algebra. This is actually the second page in our workbook where we talk about something known as a function. And we're going to take a look at our functions in the four manners that I mentioned earlier. We're going to take a look at them as an ordered pair. We're going to take a look at them as a graph. We're going to take a look at functions in table form. And then we're going to take a look at the function in some form of verbal discussion. All right, so a function is a relation in which the first component, x, as you remember, of an ordered pair corresponds to exactly one value of y, the second component. Now, what that means is that for each value of the independent variable, exactly one value of the dependent variable y gives us a function. And here's that function notation that I referenced in the previous video. So we're going to take a look at this guy here that's in the middle of the page. And if you take a look at it, you notice that we have a function given to us as an ordered pair where x1 corresponds to y1, x2 corresponds to y2, x3 to y3, and x4 to y3. So x3 goes to y3, see that mapping right there, and x4 goes to y3, that's that mapping right there. So we have one arrow coming out of the domain, and that one arrow coming out of each of these x's is a very good thing. If you only have one arrow coming from each of the input values, then you're looking at a function. Now, the fact that this y3 is shared between these two x values is fine. It's not a big deal. All of you have played with this graph before. There we go. And you know this is y equals x squared. At least I think you know that. And if you know, remember y equals x squared, let me just take 2 and -2. Those are two different x values. Both of them share the y value of 4. So it's okay for x values to share y values. That is not a problem. What's a problem is if the x value goes to more than one y value. And we'll take a look at that in just a minute. So we take a look at all of these x values have arrows coming out of them. So that makes all of these x values our domain. And then we look at the y values. Only these three have arrows coming from the domain. So the range is only made up of those three y variables. Now, example 3 says, explain why the relation in example 2 is not a function. So this is the one we're talking about right here, the one with Joe and Todd and Matt, okay? So in example 2, Joe, Todd, and Matt, it's not a function for several reasons, and I'm going to try to look at it in different ways. But if you notice, looking at this mapping, Joe has 2 arrows coming from his particular input. So since Joe has 2 arrows, that means that Joe is assigned to 2 different y values. Now remember, it's one of those things where you have to think about it. When we're looking at a function, y, the range, can correspond with many x values. It's okay. But the domain, the x values, can only correspond to one y value. So if I were to write the domain of this guy, or perhaps let me write it in ordered pairs, I would have the input of Joe would map to algebra, and the input of Joe would map to English, and then the input of Todd would map to sociology, and Matt would map to biology, and Matt would also map to English. Okay, so we're looking at these values. The fact that the x repeats, or the input repeats, it doesn't just repeat there, we also have Matt repeating. The fact that the x values are repeating, meaning that they are assigned to a single x value, is assigned to more than one y value, makes this fail the function rule. And if you have your x values repeating, then it is not a function. So I'm simply going to say in example 3, explain why the relation in example 2 is not a function. It's because the x values of Joe that have more than one y value. Okay, so once again, this is a function. Wow, I wrote that very large. Sorry. This is a function, and it's a function. If we look at the x's, they only have one arrow coming off of each x. That's a function. Over here, this is not a function. And the reasons it's not a function is what I have highlighted there. You only need one occurrence of this. We have two, but I just have one of them highlighted, and that makes it not a function. All right, so let's take a look at cars. We have Camrys, Corollas, Accords, Civics, and Impalas in our domain. Then our range is Toyota, Honda, Chevrolet, and Mercedes. What we're supposed to do is we're supposed to map between the car models with the car manufacturer. So our domain is, or happens to be car models. So Camrys, Corollas, Accords, Civics, and Impalas go here. And then the manufacturers are our range. So Toyota, Honda, Chevrolet, and Mercedes. So a Camry maps to a Toyota, and a Corolla maps to a Toyota. That's okay. Okay, a Camry only maps to one manufacturer. It's not a Toyota and a Honda. It's just a Toyota. And a Corolla maps to one manufacturer. An Accord maps to Honda. A Civic maps to Honda. And a Impala maps to Chevrolet. So we take a look at the X, and each one of these input values only has one arrow. And that's okay. So this is a function. And if you like to look at things as ordered pairs, you could write a series of ordered pairs here, where you have the model going to the manufacturer. And if you take a look at that, you'll notice that as we look at our x values, they're only written once. The y values repeat. It's okay. The x values are not repeating, so that makes it a function. Next, we need the domain. So the domain is made up of Camry, Corolla, Ford, Civic, and Impala. And the range is made up of the manufacturers that have arrows to them. And that happens to be a Toyota, a Honda, a Chevrolet. Next page in our workbook continues these examples. We have mappings with tables, and then we have ordered pairs with graphs, and then we get to take a look at some very small dots and decide if they represent a function. So starting with the mappings between ordered pairs and their table, let's start off on the first one. We have the first function as inputs of -2, and then 3, no, excuse me, 2. Now let me just say, I am in the habit of putting numbers in order. You certainly don't have to have them in order. When you fill in your mapping, it just makes it a little bit easier to check and see if it's a function or not. So -2, and 2, 3, and 4. And then over here on the range, we have -3. I guess I'll put a little line under those. And then +3. And then 5. Okay, so we have our inputs and our outputs entered. Let's start mapping them now. -2 goes to a 3. 4 goes to a -3. -2 goes to a -3. And that's where, right there at that point where you have two arrows coming from one of your x values, you can say not a function. Of course, you could have said it above as well when you were looking at the inputs, and you notice that -2 repeated right there. When the x repeats, it's not a function. let's see, I did 4. I did -2. Let's do 3. 3 maps to 5. And 2 maps to 3. All right, so there's our mapping. And then if we wanted to do an input and output, just as before, our x values are -2, 2, 3, and 4. And we'd say that -2 maps to -3 and +3. 2 maps to 3. 3 maps to 5. And 4 maps to -3. The domain is as I have listed. These 4 x values. And the range, I'm going to get it over here because it's easier to see, are these 3 y values. All right, so for the next one, you might want to pause the video and fill in your workbook B and make sure you've got this down. So go ahead and pause it. And now I'm going to fill this in as well. So taking a look at my x values, I'm going to start with -2, then -1. So little check marks there. And then I'm going to have a 2, a 4, and a 5. And then on the y values, taking a quick survey, we've got -3. We have 2. And then we've got a 3. Okay, so I've already surveyed this and declared it's a function, just looking at the x values that are given to us. All of the x values are unique or distinct. They do not repeat, and that makes it a function. If we wanted to do the mapping now, I'm going to look up here and do my mapping. -1 maps to 2. -2 maps to 3. 4 maps to -3. 2 maps to 3. And 5 maps to 2. There's my drawing. I'm going to fill this in from left to right, smallest to largest. Oops, I said that, and I didn't do it. That's a clue. So -1 maps to a 2, -2 is a 3, +2 is a 3, +4 is a -3, and +5 is a 2. The fact that we have these repetitions down here in the y is okay. Remember, y can repeat all at once, as far as the function works. X cannot repeat, but y can. So the domain, I'm filling it in from my mapping diagram. I'm just taking these numbers over here that have arrows. And then my range, I'm pulling from this. Okay, so the next example, we're going to plot these ordered pairs, The only thing I have to warn you about is check your scale every time. It changes on these graphs. It's not very consistent. So as we take a look at this scale, notice that it is a scale of 1. They have the even numbers marked. So we go through here. And let me also say, as you're working through this workbook, sometimes you'll be trying to plot something and there won't be room on the graph for the number you're trying to plot. And just take your best educated guess about where that point would be. And I have an example coming up in just a minute, so you'll see what I'm talking about. All right, so starting off, the first relation R, I'm going to graph it right here. This is a relation. We have -2, +3. So there's that one. -2, +3, x and then y. 4, -3, so I'm going to go across the x-axis to 4. I'm going to go up the y-axis to 3. Oh dear. Excuse me, I'm so sorry. I was so focused on the scale. That is a -3. So across to the +4 on the x-axis, then down to the -3 on the y. And then -2, -3. So -2 on the x, down to -3 on the y. 3, 5. Let's see. 3 on the x, 1, 2, 3. Then up 1, 2, 3, 4, 5 on the y. 2, 3. It's 2, 3. And then 5, -1. 5 on the x, 1, 2, 3, 4, 5, -1 down. And then 3, -2. 1, 2, 3, 1, 2. Okay, so now the next question is, is this a function? And the answer is no, it's not a function. We look right here along the x, we see that -2 is repeating. Or we can look here and see that -2 is repeating. Now, are there more repetitions? Sure, there's more repetitions on the x value. We got a 3 repeating right here and right here. But remember, you only need one instance when the x repeats for it not to be a function. So this is not a function. Let's take a look at f. This function right here that's given to us. We have -1, 2 as our first point. I'm starting right here. And then -2, 3. 1, 2, 3. Of y. 4, -3. 1, 2, 3, 4. 1, 2, 3. 2, +3. 1, 2, 3. I was right there. Now I'm at 5, 2. 1, 2, 5. Up 2. And then 6, 3 over to 6. Then up to 1, 2, 3. And then -6 all the way over here. And then 1, 2, 3, 4, 5. Now, you do see some repetitions in here, but notice all the repetitions are on the y, not the x. We're okay with this. So you can remember it's coming up in the next video of this section, something called the vertical line test, where if you drop a vertical line and it hits 2 points in your relation or your whatever you're graphing, then it's not a function. So right here, I'll drop that vertical line and hits it in 2 points. That means it's not a function. Over here, if I try to drop a line, vertical line through all of these, it's not going to hit another point. So yes, I mean, we do have some y's repeating, but that's okay. Y can repeat all at once. It's the x that matters. And since the x does not repeat, it is a function. So let's take a look at these. I'm going to make this a little bit larger so we can see it better. We have some little dots all over the place. And as we look at these little dots, if we try to visually inspect it, we can see that the x values, if we drop vertical lines, the x values are only hit once by any vertical line that I drop. So that makes this a function. We go over here to this guy, a little bit bigger. Let's see here. I see a problem already. There's another problem as well. But this problem stood out to me. If I drop a vertical line here, it hits both of these dots. It would if I could draw a vertical line. But pretend it was vertical, a straight line. If you drop a vertical line right there, we have some x values repeating. Now, at this moment, I was a little casual about this, but let me remind you, the x values are along the x-axis, of course, and they're represented by vertical lines on our grid. So on this vertical line, all of these values on this line represent the x equals 6 right here. So right here we have 2 values of 2 repeating right here, where 2 values are repeated, and that makes this not a function. Now there's other repetitions. I believe if you look at the y-axis, which represents x equals 0, everywhere along the y-axis, x equals 0, we've got 3 of them repeating, and that as well makes it not a function. All right, so our next video is on the next page of our workbook for section 1, and it's going to deal with the algebraic formulation of functions.